Consider the curve 9x squared plus 16y squared is equal to 144 in the xy plane. Is the point 0, -3 a relative maximum, relative minimum, or neither? Well, in order to answer this question, we first have to find dy over dx, or the first derivative of our curve. And since our curve equation contains an x variable and a y variable, we're going to have to use implicit differentiation. So let's go through that process. When we differentiate 9x squared with respect to x, we will end up getting 18x. And then if we differentiate the next term with respect to x, we will get plus 32y times dy over dx. And then we have is equal to, the derivative of any constant, including 144, is 0. And now we can solve this equation for dy over dx. We're going to subtract 18x from both sides, and we'll get 32y times dy over dx is equal to negative 18x. And then if we divide both sides by 32y, we will get that dy over dx is equal to negative 18x divided by 32y, which then reduces to negative 9x divided by 16y. Now let's evaluate this at our point that they're asking us about, 0, -3. We will get negative 9 times 0 over 16 times 3. So we'll end up getting 0 over 48, which is equal to 0. And when your derivative is evaluated at a point and the result is 0, that means we have a horizontal tangent or relative extrema. So it's definitely not cannot be determined, and it's definitely not neither, because we know it's one of these two. And in order to figure out which one it is, we're going to have to calculate the second derivative and test the point to see the concavity to provide us with that answer. So let's go through that process also. So we're going to have our second derivative of y with respect to x, and we're going to be taking the derivative of this. And notice we have a quotient here. Therefore, we're going to have to use the quotient rule. And the quotient rule is the bottom, 16y, times the derivative of the top, which is going to be negative 9, minus the top, negative 9x, times the derivative of the bottom, which will be 16 times dy over dx, all over the bottom, 16y squared. And now let's simplify this. Negative 9 times positive 16 will give us negative 144y. And notice this minus negative will become a plus positive. So I'm going to put the negative number in this top expression second. So we'll have minus 144y. And then as our first term, we're going to have 144 times x times dy over dx. And then when we simplify the denominator, it's going to be 256y squared. Notice we have a dy over dx here. And we already know what dy over dx is. It's negative 9x divided by 16y. So we can take this rational expression and substitute it in right here and simplify further. So we're going to have 144x times negative 9x divided by 16y minus 144y Then that's all divided by 256 y squared. Notice that 144 is divisible by 16, so the 16 becomes a 1, and the 144 becomes a 9. And we are still going to have a y, though, in this denominator. So in order to combine our first term and second term together in the numerator, we're going to have to multiply our second term here by y over y. And now when we evaluate this and simplify, we will get negative 81x squared minus 144 y squared, all divided by y. And then that is all over 256 y squared. And now we are going to multiply both the numerator and denominator by 1 over 256 y squared. And we'll end up getting negative 81 x squared minus 144 y squared, all divided by 256 y to the third. And now if we evaluate this, our second derivative at our point, so we're going to have our second derivative at the point 0, negative 3, that will equal negative 81 times 0 squared minus 144 times negative 3 squared, all over 256 negative 3 to the third power. Well, this first term goes away. Negative 3 squared will be positive 9, and positive 9 times 144 will be negative 1,296 divided by 256 times negative 27, which is going to be negative 6,912. And two negatives make a positive. You could reduce this if you'd like, but the key here is that we have a positive value, meaning that we have a concave up graph at this point, or concave up section of the graph at this point, making the point 0, negative 3 be a relative minimum, or answer choice B.